A map is an unordered group of key-value pairs. The keys and values can be of the same or different types. The elements or values in the map are indexed by a set of unique keys. Although the values can be of any type, the key must be a comparable type, meaning that they should support the comparison operators equal to and not equal to. The basic types like booleans, integers, floats, and strings are comparable types. Struct types are comparable if their fields are comparable, so they can be used as keys of a map. Go doesn't support the comparison operators equal to and not equal to for slices, maps, or any struct type with a field whose type is incomparable and arrays whose element type is incomparable. So these types cannot be used as a key in a map. They still can be used as values. Although slices are not comparable, arrays are comparable if their element types are comparable. Two arrays are equal if their element values are equal. The elements are compared in ascending index order. The comparison stops as soon as two element values differ. So it is possible to use arrays as keys of a map. Although maps or slices can't be compared to another map or slice or itself, they can be compared to nil. The next thing is not specific to maps but also applies to slices. If you are using composite literal types as keys or values of a map, you can omit to specify the type when specifying values. For example, here we use the person struct as the keys of the map. The values are a slice of integers. The same is true for slices also. For example, here we have a slice whose elements are pointers to a slice of integers. The zero value of a map variable will be nil. If you try to put some value in a nil map, the program will crash at runtime. Retrieving value from a nil map works and will return the zero value of the element type. In this case, the value type is an integer, its zero value is the number 0. So a nil map is not very useful. An empty map can be created like this. The difference between a nil map and an empty map is that for a nil map, no memory is allocated, but for an empty map some memory is allocated to hold a small number of elements. You may also create an empty map with the built-in make function. The built-in len function can be used to get the number of elements present in a map. The built-in make function also supports specifying a number as a second argument when creating a map. Then the new empty map allocated will have enough space to hold at least that many elements. A map's memory grows similar to that of a slice we have seen in the previous video. When you add more and more elements to a map, at some point, new memory is allocated with enough space to hold twice the current number of elements, and the elements are copied from the current map to the new map. So if you already know the maximum number of elements your map will need to hold, allocating all memory at once will be more performant because it avoids all those need for growing the map and copying elements. Maps are pointers. When you create a map and assign it to a variable, the variable is a pointer to some memory location where the elements will be stored. When you assign a map variable to another, only the address stored in that variable is copied to the new variable. Now both variable points to the same memory. So any modifications like appending or deletion done through one variable will reflect on the other also. Since maps are pointer types, you don't need to pass a pointer to a map when passing them to another function. Any modifications done on the map inside the function will reflect on the original map. One interesting property is that the elements of a map are not addressable. If you have a map whose values are container types, you can modify the elements of those values. For example, here the values of the map are a slice of integers and I'm modifying an element of one of the value slices. But if the values were struct types, modifying the fields of the struct is not possible. If you try to access a non-existing key in a map, Go returns the 0 value of its value type. If the Go compiler allows us to modify the fields of a struct directly after indexing a map, we would be able to change the fields for a key that doesn't exist in the map. The way to modify the struct fields is to get a temporary copy, modify the fields, and assign it back. Maps can be iterated using the for loop. The order of the elements is not guaranteed to be the same on each iteration. Similar to slice iteration, the memory for the loop variable's key and value is created only once. Each key and value in the map is copied to that same memory location on each iteration. Since each item is a copy, modifying the direct parts of it won't modify the actual value. For example, here we are trying to iterate over the map and set the age field of all values. This doesn't modify the map elements since the loop variable value gets a copy of the map element, and we are modifying that copy. Note that if the elements had indirect parts, the modification will change the element in the map. For example, here the elements or values of the map are a slice of integers. We have seen in the previous video that a slice header contains a length, capacity, and pointer field. Only these fields will be copied to the loop variable. Since the new copy of the slice header also points to the same memory for elements of the slice, modifications will persist. If you want to clear the entries in a map, you can use the built-in delete function. You need to iterate over the keys of the map and call the delete function passing the map and the key. This loop is specially optimized for fast execution. One thing to note here is that it doesn't deallocate the memory allocated for the map. It only removes the entries. The memory allocated for the map will be reused when you insert it into the same map again. As of now, Go doesn't provide any option to shrink the memory allocated for a map. If a relatively high memory is already allocated for your map and when reusing, you will be inserting a high number of elements to the map, then prefer looping and deleting the elements so that the memory allocated can be reused. If you will only need a smaller number of elements to be inserted and want to use the same variable in the rest of the code in the same scope, you can allocate a new map. The garbage collector will eventually free the memory allocated for the large map as long as you are not referring to it anywhere else in your code. A set is an unordered collection with no duplicate elements. One use of a set data type is to get the unique elements in a slice. The Go standard library does not provide a set data type. We can use the map as set since the keys of the map will be unique. The data type for the value of the map can be anything when we use it as a set. Here we used a Boolean data type. A bool data type takes 1 byte of memory. The convention is to use an empty struct as the value type when using a map as a set. The reason for this is that an empty struct is a zero-size type and doesn't need any memory. The size of a struct is the sum of the sizes of all of its elements, and some padding. Since an empty struct doesn't have any fields, it doesn't take any space. Sometimes using a bool as the value instead of an empty struct will allow you to write better code. For example, assume your use case for using a map as a set is to check if an item exists in a collection. If you were to use the empty struct as a value, you will be using the two-variable syntax for checking if a key exists in the map. The second value will be a Boolean which will be true if the key exists in the map. If you were to use bool as values, you could write code like this. You may choose an option depending on your preferences. In the next video, I will cover some of the internal implementation details of map data type in the Go language.